Pero la perdí a ella, ¿cierto? Pero, ¿cómo llamo?
Settings. Nautilus. Cancelar. Directamente. Y si quieres ese enlace
¿Para los estudiantes?
para los estudiantes.
Bueno, creo que feedback ahí. No hay nadie. Oh, hi Nicole.
Hello, Juan. So our they joined you remotely.
A little problem, but now it's okay.
Oh, good.
Okay, well, so where are you now? At the well, let's see how you call it, the telepresence center of the trust.
It is. It's located at the University of Rhode Island. I'm in my office right now, but we do have a big hub for telepresence here.
Okay, I think this is one of the most interesting points. If you can tell us a little bit about it, would be fantastic.
Sure. Are you interested in me going through some slides still, or would you rather have it be mostly?
Oh, yeah, no, that's fantastic. I was just giving some time if there were some other. I just sent a new link to my students.
Sure.
So if some of them, but I think we can go ahead and go through your slides.
Okay. This is interesting. So most of your students, or all of your students, aren't in the classroom with you. They're somewhere else.
Yeah, I'm streaming in YouTube Live at the moment, and they are they're following the Nautilus, and they are following this. If they can see us live, they can go to the video later. But I hope they are joining us at the moment.
Okay. All right. Well, I'm happy to share my screen and get started with a few slides. Actually, I tried to cull it down. It ended up being 40 slides. You could stop me at any moment.
No, that's okay.
Okay. And do you have a forum or a way to take questions from students, or?
Yeah, well, we have a chat here or in YouTube, and so yes, we will write down the questions and do it after your presentation, if that is okay.
Oh, that sounds great. All right.
All right.
All right. Well, I guess I'll say hello to Juan's students. I'm joining you guys from the University of Rhode Island. I work for a nonprofit organization called the Ocean Exploration Trust. And I'm going to show you a little presentation today about how we do science and exploration, and a little bit about the tools that we use and the difference between exploration and science. So with that, I'm going to share my screen. And
yes,
I will go through some slides that mostly have images of things that I can't show you here from my office. I am amazed by this class. I'm intrigued by the fact that you guys are doing everything through telepresence, essentially, which is a very important part of our ship. So we'll get to that. Let's see. The goals of our program are to develop technology that allow us to go to the deepest parts of the ocean and to study or explore them. We also developed the tools to help with education and outreach. So part of that was developing the telepresence technology, which is really a series of satellites and a downlink here at the Inner Space Center in Rhode Island that allow us to distribute what we're doing on the ship in real time to classrooms and anyone who's interested through the Nautilus Live website. Second goal is to explore the unknown parts of the ocean. So most of the world's ocean hasn't been explored, especially parts below, say, 100 meters, which are relatively inaccessible. People can't go there through scuba, so we send robots, and I'll show you the two that we use on our ship, the Nautilus. And finally, a large part of our program is education. So we hope to motivate and inspire people from the earliest kindergarten or earlier, if possible, through old age to want to know more about the ocean, want to learn more about engineering, mathematics, technology fields, and especially as they relate to ocean sciences. My personal motivation, which I think is very important, is to ask yourself why you're interested in something, why you're going to devote your life to it. Is I always wondered what was down below the surface of the ocean. The picture on the right side of the screen is from Santorini in Greece, the Mediterranean Sea. And so it looks like a very calm ocean.
Could you share your screen? I don't think I got it here.
Ah, you don't see it.
Yeah.
Let me try again. I apologize.
No, it's all right.
We'll find the Hangout window again. Application window. There's screen. Aha. Do you see it now?
Let me see. There you go, yeah.
Ah, okay. Sorry about that.
That's pretty cool.
So the picture here is showing Santorini. And so this was the first area I started doing deep sea exploration in the Mediterranean. And we were looking at an area that's very volcanically active under the sea, and people are very worried about the potential for another volcanic activity event that might impact humans living on shore. So we were looking at these vents that are very active. This one I think is called the Champagne vent for obvious reasons. It looks like a bubbly bottle of champagne at the bottom of the Mediterranean Sea. And so I've always just had a curiosity to know what was under the surface of the ocean. To help frame what the difference between science and exploration is, I always show the scientific method. So you guys are probably familiar with the the steps of the scientific method, where you have some information going in, you ask a question, you do research to help you understand how to frame your question, come up with a hypothesis, and do an experiment to help answer that question. You analyze all of the data you collect, and then you reach a conclusion that can help you start the process all over again. With exploration, it's a little bit different. There are many areas of the ocean that we know very, very little about, so it's hard to have enough information to even form a proper hypothesis or form enough detail to have an experiment. And because of the way science is funded, which is mostly through the government, oftentimes you have to have a really strong hypothesis and experiment to get funded. We're lucky enough to have an organization in our government that is willing to take a risk and fund some very experimental exploration in our ocean. So the types of things that we look at for exploration, I liken it to being a detective, is you want to know what's weird, different, or new in an area. So oftentimes we'll look at just a map of the world's oceans and pick an area, do some research on what has or hasn't been done there, and try to figure out why we should go to that area, what's compelling about that area. Maybe it's something about the currents or something about the sea floor. Maybe it's something about organisms or something that others have seen in that area. But we formulate sort of a very general question about that drives why we should go to a new area. And sometimes we're figuring out what's changed. So oftentimes in ocean science, you only have maybe one data point, one cruise to an area, and you want to know how something's changed, perhaps in the last minutes, but more often in the last decade or the last several years. And when we go to a spot, we always assume that we might be only going there once, and we might be the only people to ever explore that spot. So we have to make sure that we're equipped with all of the technology and the knowledge when we go there to make the best decisions about what should be done, so that we can gather the most information and we could come up with compelling evidence, reasons why the government or someone else should fund us to go back and take a better look at the area in the future. So we do that on our ship called the Nautilus. This is a ship that's quite old. It was built in 1967 and was acquired in 2008 by the Trust when we were in the Mediterranean Sea. We have 31 science staff on board, and the scientists include a wide range of people. They are the scientists, the science team, our data loggers, who are often students or interns, engineers for both the remotely operated vehicles for piloting and fixing those vehicles, and also video engineers for making sure that the video that's coming back from the robots is the highest quality possible. Of course, a satellite and data engineer to make sure that all of this information that we're collecting is able to go to shore through the Nautilus Live website. And educators. We bring out teams of educators, one for each watch on the ship, that can help communicate our science to shore. The crew is also 17 non-science crew who help run the ship. They're the cooks. They're the ones who drive the ship and keep everything working in the engine room, to electricians. Let's see. The next thing I wanted to talk about a little bit is how we plan our expeditions. I touched on the fact that we're going to places that people know very little about. And so how we decide where the ship is going in any given year is based on a workshop that we hold for an area that the ship is going to operate in over the next several years. So right now the ship is in the Eastern Pacific Ocean, and it's been there for the last 2 years. We first started by asking scientists from around the world to write papers for us, just a short 1 to 2 page paper about where they would go to explore the ocean in the Eastern Pacific if they had our ship and our capabilities. And so you could see all of the white dots on this top map here. Those are all of the areas that scientists have recommended that we go in the Eastern Pacific. We held a workshop to sort of define regions of exploration that we might be able to work on in one given year, and then broke those down into more definable regions. And so you can see these different color boxes here actually represent different disciplines. So geological, biological, archaeological, chemical, and physical oceanography. And so scientists put together where they would go based on asking questions about those various subdisciplines. And then the bottom boxes here are refined based on looking at regions where for a 7-day to maybe 14-day cruise could we go to answer some of these questions that touch on all of those subdisciplines. So when we go out on a cruise, we don't just focus on biology or just focus on archaeology. We want to cover everything if we can. So these are the regions that we're looking at for the next several years. And right now the ship's actually in Victoria, Canada, and headed down to Los Angeles, California on a mapping cruise before the next remotely operated vehicle cruise. So how do we explore the ocean on Nautilus? We usually map an area first. So the seafloor is largely unmapped, although you might go to Google Earth or look at the images of the seafloor and see that there are pretty well-defined mountains and trenches. The resolution of those maps is very poor, and most of that data is satellite derived. So we go out with a ship that has a multi-beam sonar to map the seafloor and get more detailed images so that we can choose dive locations more intelligently. We also have a sub-bottom profiler on the ship. This allows you to see below the surface of the sediment. So you're looking at maybe 50 meters of sediment packages that will show you where things like old, old levees or old channels are. also areas where perhaps oil or gas are being released in the shallow subsurface. So you're able to kind of put together a couple of different types of mapping technologies to give you clues to where you should look, what are the interesting areas. Here's a picture of Mars that was taken from many satellite images. And the reason we have more detailed images of the moon and Mars than we do of Earth is because the Earth is covered in water and the moon and Mars are not. So here again, these are from orbiting imaging satellites around Mars that can make very detailed maps of Mars. So with the Earth, we actually have to send ships out if we want really high resolution maps. And that's why it's taken us so much longer to map our oceans than it has to map foreign planets and bodies. When we do map the seafloor, we're able to derive many different important products, including the bathymetry or topography of the seafloor, so that most often we're looking for areas that aren't just flat mud, although there are scientists who like to study basins. A lot of the times we're looking at canyons or trenches or seamounts, something with some relief. We're also using these maps for situational awareness. You can imagine when you're navigating a robot that's miles down from the surface ship, you have to be very careful and know where you are, where the steep walls are, so that you can make sure that you keep your technology, your gear safe. We also look at a product called the backscatter, which is a measure of the reflectivity of the seafloor. So how strongly is sound reflected from the seafloor? And this tells you something about what the geology of the seafloor is. So very reflective areas tend to be harder rock. So those are areas that you tend to find things like coral and sponge habitat because they need something to attach to. Whereas the darker areas, the less reflective areas, are indications of mud or softer sediment. And again, there are reasons to study those areas, but they tend to be slightly less interesting for things like habitat characterization. Here's an image of the ROVs on the back deck. These are remotely operated vehicles that can go to 4,000 meters. We always operate the two of them. You can see Hercules is in the air on the crane being moved over the side of the ship to deploy for a dive. And then Argus is sitting on the deck here. Both have HD video cameras. Both have some navigational sonar so that they could avoid bumping into things. And Hercules is the one that has all of the sampling gear and oceanographic sensors like CTDs that measure conductivity, temperature, and depth. A close-up of Argus shows that it also has a lot of lights around it. So one of the main things Argus does is light the seafloor. The areas that we're going to are completely dark, so it's important that you bring all your own light with you. And it also has the HD camera, so you're able to keep an eye on Hercules and have sort of the two views, one of Hercules working on the seafloor and one from Hercules focusing on whatever it is that we're interested in looking at. Argus also weights down all of the cables. So Argus is attached to the ship via a fiber optic cable, which is how we get the video and data streams back to the ship and then out over the internet to people on shore. And so all of that cable weighs a lot, but it's also moving up and down with the ocean. So Argus is very heavily weighted so that it can keep that cable down in the ocean and prevent a lot of motion that would make it hard to operate Hercules. Here's a picture of Hercules actually doing some sampling of corals in a region, and you can see all of the lights on the front of Hercules. Its arm, the one that is out taking the sample, is a very dexterous arm that's able to have different attachments to help it either cut coral, or you could pick up a scoop and scoop things up. You can pick up a vacuum cleaner attachment and slurp samples as well. So it's a very useful arm for taking different biological or geological samples. If we look at the side of the vehicle, you can see all of the different sampling gear. So these are push cores along the side that have these balls on top that make it easier for the arm to grab. The engineers who have built the vehicle have had to think of lots of different tricks for making things easier to operate under the water. And so putting things like these large holds for the arm to grab make it easier. The drawer that those push cores are sitting on is actually watertight, so that when you shut samples into it at depth, it keeps the cold water in and it keeps the samples fresher. It's very important that you try to minimize the degradation of samples as the vehicle's rising through the water column and into warmer waters on a recovery. I mentioned that we have a vacuum-like sampler, and this is showing a close-up of that sampler. You can see it's actually 8-chambered sampling device, so you can take 8 discrete samples. Usually we take 7 and reserve 1 as a flush jar. And each jar can sample sub-environments of things that you can't normally pick up with the arm. So it can sample very small things like these clams from a vent site, and then you find other things in there like these polychaetes. So everything, once it gets to the lab, is actually sorted out and preserved, and I'll talk a little bit more about that in a minute. You can also see that we can take water samples. So the port side, or the left side of the vehicle here, has usually 6 Niskin bottles that can be individually triggered to take water samples at sites. And sometimes there are chemists or even people who are studying the DNA that's shed from organisms. I'll talk a little bit more about that in a few minutes. Want water samples for these reasons. So here's an image of our lab. You can see we have a microscope on board at times that allows biologists or other scientists to view the organisms that come up as samples. But mostly what we're doing is kind of sample triage. So you can see that there are usually somewhere around 20 samples that come up per dive. And so you kind of work for the next 6 to 8 hours to photograph the sample, take notes on the samples, and depending on what it is, preserve it. So biological specimens are often put in ethanol with a subsample for DNA. And rock samples are often just taken, you just take notes on it, measure it perhaps, take off any organisms that were living on it as a subsample. And we do have a rock saw, so we could cut rocks in half to kind of view their interior structure if we want on the ship, but oftentimes we just air dry it and send it out to scientists. You can see we have a fume hood for using different chemicals as well. And then this picture here actually shows our gym space. So there's a hole through the ship called a moon pool that allows us to deploy instruments all the way through the hull. We do that occasionally for things like water samples or tracking things like AUVs. So we'll put down a tracking beacon. So this lid lifts off the cover here, and you can access the water through the ship, which is kind of neat. All of our work that we do is from what we call our command center or control van on the ship. So while we're out at sea, we work 24 hours a day. Ship time is very expensive. And so we want to make the most of the time that we're out there. So we stand watches, and on our ship, it's 2 4-hour watches a day. So you're on usually, let's say 8 a.m. till noon, and then 8 p.m. till midnight would be 1 watch. And your job as a scientist is to take notes on everything that's happening. So you want to take down as many notes as you can from what you're seeing. And you can see as we sit in the van, we see the 2 different vehicle cameras. We also take notes on what samples we're taking and why we took them, where we took them. There's a person whose job it is to navigate the ship, meaning they talk to the bridge. They talk to the mates who are piloting the ship and tell them where we need to go. 2 pilots are also standing watch, 1 for each vehicle. We have a video engineer on each watch and a science communication fellow, or our communicator educator as well. And as I mentioned, each watch has a mix of people with different abilities. So some people, especially the watch lead, is a veteran scientist who's been in the field for many years, sometimes decades. But oftentimes we also have interns or people whose first time it is on the ship. So here's an image just kind of showing what telepresence is all about. We've talked about it a little bit. So there's a satellite on the ship. We send up the video and some of the data. It goes to the Inner Space Center. This is actually an image of the Inner Space Center at the University of Rhode Island, where scientists can stand watch remotely. And then all of the data is spread through the internet, through Nautilus Live, to places around the world where anyone can watch. And that's how we're also able to increase our scientific participation. So scientists are able to join us from their home institutions or their homes and help us run cruises from there. One of the really important features about our ship that makes us different than traditional scientific vessels is that all of our data and samples are open access. This means that we want to share the science that we do with anybody, because the idea is that we're collecting just enough data for someone to maybe write a short paper or write another grant to come back to an area. So data can be requested from us at Ocean Exploration Trust, and samples can be requested from our partnering repositories. Biological samples go to Harvard University, and geological samples are housed here at the University of Rhode Island. And so you could see this map is showing where all of our biological samples have been taken in the last couple of years. Just to give you a sense of what one cruise season looks like, I've posted what the 2016 season statistics were. So we did 9 cruises last year, and we were operational for 130 days, so just under half a year. This year we're just over half a year. Sorry about that. We conducted 88 ROV dives, and that was the equivalent of about a little over a month of time spent in the water, spent on the seafloor, looking at, exploring the ocean. We collected 550 samples just about, and those are all broken down into many subsamples. And we spent about 50 days mapping. So you could see the different areas from Victoria, Canada, down to Southern California, where we worked last year. And of course, the results of exploration, the keys here are discoveries. So that's what we aim for. We aim for making discoveries as we go out. Here's an example of what we can discover on a mapping transit. So we were transiting from the Galapagos Islands up to California, and we found a number of things, including seafloor features that were not part of any mapping data. So here you can see the various sources that we looked at. And our data next to it. So we found a little abyssal hill off of Mexico, and we've found a lot of seeps. I'll talk a little bit more about that in a minute. Here we are in the Galapagos, returning to the site where vents and chemosynthetic life was first discovered with a tube worm. This was a worm tube that's 13 feet long. It was pretty interesting, pretty gross actually when we got it up on deck. But what we were doing there is looking at a vent Tempest fugit that scientists had discovered but not been able to sample before to see what lives there. And so here's the result of our mapping. This is high resolution mapping. These are all images that were stitched together to produce a photo mosaic of the vent. All this white cloudy area is where the venting is active. You can see all of the white area between these rocks are actually organisms. They're these giant clams that were actually mostly dead. And then a lot of the samples that we took that are being looked at by scientists now through slurp samples or other types of samples are shown here as well. So we're looking at the different sub-environments. We've also done quite a bit of work on seeps. I mentioned in the Gulf of Mexico, we were looking at a seep that actually disappeared. So there tends to be an on-off behavior of these. These are plumes of methane that are emanating from the ocean floor. And this plume 3 was present on April 14th and not present 4 days later. And what we saw when we went back one day was actually an explosion of methane. So this is a before picture, and this is an after, where there's a sudden release of methane. These vents tend to become clogged at times, and then as the gas pressure builds up, eventually they seem to blow open again. So that was something unusual that we witnessed. I mentioned that we found a lot of seeps off of the West Coast, and that's become a focus of a lot of the exploration. You could see all of these red dots are areas where we found methane seeps. People care about these things because there's some question about how they might impact the climate. A lot of methane is a very strong greenhouse gas, and we don't know how much of the methane that is released from these vents is actually making it into the atmosphere. There's also some concern about their ability to cause things like landslides. And in fact, in this Southern California area, we found a landslide area that was ringed by vents. So sometimes when you have a lot of vents in an area with soft sediment, it can cause mass destabilization of slopes. And if that's big enough, that can also lead to things like tsunami, which is why it's important to understand these events, especially close to population centers like Los Angeles. We often take a look at these sites as well. So we take a look at the organisms that are living at these seep sites. Here we found methane ice, which was kind of neat, and all of these little bivalve organisms that were living at that site as well. Another area of interest that we happened upon last year on one cruise off Southern California were whale falls. So all of these push pins are showing locations of different whale falls. And you can see these were previously undiscovered, and we looked at the amount of decay and what types of organisms lived on these different whale fall sites. And you could kind of tell that this one at Santa Rosa Island is very old, whereas the 60 Mile and Patton Escarpment are slightly younger whale falls. A lot of our research has been happening in the Channel Islands region. Because it's a marine sanctuary, there's interest in understanding what kind of habitat are being protected and making sure that we've protected a large enough area off the coast of California. So you can see that there are quite a few fish, coral, different things like octopus, and here are these snails that are building all egg casings. In the Channel Islands, we also did research on coral and understanding how ocean acidification is affecting coral. So we collected these corals for a scientist who is now studying impacts of the acidification on them in his lab. So they were actually kept alive. And we found some weird organisms like this purple orb that became quite popular. It turns out it's related to a snail. It's called a velutinid, and they think it's a new species of it. So right now, these folks at MCZ are writing up a species description of it. Last year, one of our maritime heritage targets was the USS Coast Trader, which was torpedoed by a Japanese submarine off of the coast of Washington State, so within US waters in 1942. The concern was that this freighter was carrying a lot of crude oil and it might be polluting right outside of a sanctuary. So we went down to look at the shipwreck and see if the hull was still intact or if it was leaking oil. From what we could tell, it was not leaking anything. It was very interesting because it is a habitat for fish. There are a lot of these lingcod living around it. And then we've also worked with Ocean Networks Canada for 3 years now to help build their cable observatory and maintain their cabled observatory. So this is another type of ocean exploration where they get time series from a region off of Canada. All of these yellow lines are cables that connect these different nodes, and those nodes have different types of instruments, including sonars, CTDs, different types of oceanographic instruments and sensors, sometimes cameras. There's a robot down there called Wally that roves between places that gives people a view of the seabed for a longer period of time than we're able to stay down. So we go out there and help them re-instrument and sometimes deploy new sensors on their platforms. We also, as I mentioned, do a lot of work to try to push forward the technology that we use to look at the deep sea, to study the deep sea. Oceanographic sensors, especially ones that can go to depth, can be very expensive. So last year, some scientists who came out with us were interested in testing out really inexpensive sensors. So this is a honey bear bottle. It's something that usually contains honey on our ship, and scientists put some sensors in there to measure temperature, and we actually compared it to the temperature reading that the very expensive sensor on Hercules has, and it compares quite well. So what we're interested in is helping researchers or even students at universities test out or develop technologies that can help them get measurements in the deep sea for relatively inexpensive amount of money. Another thing that's of interest, of course, is new sampling technology. It can be very hard to pick something up that is very delicate in the deep sea with the sort of steel, I think they might, grabbers or claws that we have. So scientists have developed these squishy fingers. They are hydraulically activated and just kind of give the organism a gentle hug. This is a holothurian, which is a kind of sea cucumber that was living off the coast of California. And you could see there are two more here. We picked this guy up and then just put him down, and he went about his business. So we're working with them again this year to see, to test out different types of these soft manipulators. Another thing that we're doing is trying to develop ways of studying the organisms in the ocean without having to take samples. So we try to be as environmentally friendly when we go to a place as possible. We don't want to disturb or destroy a habitat, especially in the deep sea where it can take hundreds of years for these coral to get to the size that we're seeing. We'd rather not have to sample them, but in order to tell what they are, until recently, scientists have had to take at least a little piece of the coral. Scientists at NOAA, led by Meredith Everett and Linda Park, are developing what's called eDNA for coral identification. This is taking a water sample near the coral, and because those coral are shedding cells in the region, they can then filter that water and run DNA tests on the filtrate and tell what kind of coral were there. So the way we're helping them is by being able to ground truth the water samples that they get. So we'll take a water sample and we'll also take video. Occasionally we take a small physical sample, a small piece of the coral, and then Meredith can run the samples in her lab and tell what kinds of coral there were in that area and refine her methods. Another piece of technology that we used was a hydrophone to listen for bubble plumes. This was kind of interesting because the remotely operated vehicles are incredibly noisy. And so we didn't know if we'd actually be able to hear anything besides the ROV noise. In this case, we put a small hydrophone down and went about 2 kilometers away from it, and were able to hear bubbles. This was, again, scientists working at NOAA in the Pacific Northwest, and they were able to hear the bubble plumes. This is their data. So we hope to do some more work with that in the future because there still was quite a bit of noise that they had to remove from the ROV. We've worked with a scientist who has a 360-degree camera, and I wish I could show you guys the video of this because it's really spectacular. It was put on Herc's light bar, so the front of Hercules, and when you put the Oculus goggles on, it feels like you're sitting on Herc's front porch and you could look around and look up and look behind you, and it's a totally immersive experience. It's really neat. They're trying to get these types of videos out to planetariums. I believe this one was shown at the Hayden Planetarium and also the Franklin Institute in Philadelphia. It's something we hope to continue to work with in the future. And then wrapping up, this is what our expedition season looks like for this year. So we've done just one cruise off of Canada that's actually not shown here. And so we have all of this work left to be done. We're going to start with the Channel Islands cruise starting the early July, and then work our way up the coast and then end our season in Mexico. So briefly, in the Channel Islands, we're interested in looking at submerged shorelines. These are shorelines that were subaerial, above water, during the last glacial maximum and are now usually about 100 to maybe 300 meters below the surface. And we're finding things like these massive mudstones that are normally found on beaches, but are, again, this is, I think, at 170 meters water depth. And we're finding them using our mapping data and then taking a look at them with the ROVs. So we're interested in knowing how these submerged shorelines have been colonized and trying to constrain the age on them a little bit using some, taking some samples for scientists to look at. When we get to Mexico, we're going to be studying the Socorro Islands and San Benedicto Islands, where there were volcanic eruptions in the recent past, as far back as 1848 and as recently as 1993. And so this is subsurface volcano, but in 1993, there were boats close enough to see pumice floating in the water. And so it's a very interesting area to go take a look at the volcano, what happened after the eruption, and how it impacted the seafloor and habitats. And it's a very interesting area to explore habitat because it has such a diverse and interesting megafauna. So there are these white-tip sharks, there are these giant manta rays, amongst other things. This area is called the Galapagos of Mexico. So there should be a lot of really neat things to look at. We're also studying the carbonate vents in the Pescadero Basin. So this is just inside the Gulf of California. These vents were discovered by Mbari a few years ago, but they're really unique because they're only the second carbonate vents that have been discovered. So these white carbonate formations, the other is located in the Atlantic Ocean. So we're going to go look at the chemistry of these vents and also how, again, they've been colonized by organisms. So if you're interested in more information about the science that we've done in the past, I would suggest that you look up the Oceanography Society's New Frontiers in Ocean Exploration. We put one of those out every year. They're a nice, mostly pictures with short articles about the types of data we've collected and research that's being done on it. I'm also putting together a more scientific publication in deep sea research that's due out in February 2018, and will cover the actual scientific results in a peer-reviewed format. And before I take questions, I also wanted to just point out that there are always opportunities to be involved with us. Outreach and involvement of students is very important to our program. You could watch from home on nautiluslive.org and write in questions to watch standers and have them answered live. You can also request data or samples from us and consider applying for an at-sea internship. So we have science internships for and engineering internships, as well as the science communication or educator internships that I mentioned. So I hope, Juan, that I left enough time for questions.
Yeah, Nicole, thanks so much. It's been fantastic. Yeah, you know, I'm always overwhelmed with all the exploration and all the progress that you guys have done. I have just a quick comment. I did a review of bubblegum corals back in 2005. I got just a few specimens from the Eastern Pacific of Mexico and California, and several of them, like I guess 3 species were new.
Wow.
And I'm really looking forward to see what you guys get in those areas of near the Gulf of Mexico or the Channel Islands. Seems to be like a hotspot of diversity for bubblegum corals, which are very common. Just that. I don't know if some of the attendees want to ask something. Trigal or Sebastian, or in the chat of YouTube. You have a question? Okay. Okay, someone is writing a question in the chat. Well, before that, I was also very interested to see the story about the honey bear device.
Mm-hmm.
You know, I think those are those things that, you know, people is always interested in, because this type of technology is very expensive, but, you know, there's always cheaper ways to do that. Do you have more examples of that kind of sort of like inexpensive technologies?
Well, I do. I have an example of an interface that really saved us. So we use what's called an underway CTD for doing profiling of temperature and salinity in the water column. And the sensor itself is pretty expensive, but the piece that we were able to innovate was a little computer interface with a Raspberry Pi that allows us to quickly upload the data and send it. It's important for our mapping data, so we quickly send it to the mapping program for sound velocity profiles. And it was built into a Tupperware container. So it's just a Tupperware container with a touch screen and a Raspberry Pi. And it allowed us to quickly be able to use the data that we collect. So it's always rewarding to be able to find those solutions to problems. And be able to do something, like you say, inexpensively.
Yeah, that was very interesting. The other question I have is, it's very interesting that you compare what is being done in Mars or the Moon about mapping and the how little we have done in the ocean floor. What do you think is the most unexplored area in the ocean? I know one, Colombia. We haven't done anything here, but elsewhere, what do you think is a more like intriguing place in the ocean to explore?
I mean, I think the Pacific is such a vast area that even it's hard for us to wrap our heads around how to plan a season. For example, we're looking at planning next year when we're going to expand west to Hawaii. And there's so much space in between the US and Hawaii that you want to plan meaningful stops or even mapping areas along the way. But there's so much to cover that I think the Pacific, just in its vastness, tends to be understudied. I think we also are looking at a potential project in the Arabian Sea, and I think areas like the Arabian Sea or the Indian Ocean that are harder to access are also very understudied. And then it has been interesting holding these conferences, these workshops that bring people together, because I have talked to people from Colombia who have proposed that we come there, and it's on our list. So I hope that in future years, probably we're looking at 2019, 2020, we can get past things like permitting issues, which I didn't touch on, but permitting takes up so much time to be able to get to these areas that need to be studied but are within a country's EEZ.
Yeah, we at the moment are trying to get the permit for the Alusha, and with Woods Hole, a little expedition here, and we're getting better in doing it. So we hope we can have like already a protocol and a setup for bringing you guys and in the future. So this is our first experiment. We're actually interested in a region with a lot of landslides of the continental shelf, and it's a region that might be related with cold seeps. So what you mentioned of the coast of California seems to be also happening in some area in the continental shelf at the Caribbean side of Colombia. So that was pretty insightful. Okay, I think we have a question here. I'm gonna read it. Thanks for your presentation. Your activities and results are amazing. I was thinking in the new species number that you discovered after your expeditions. How many species do you get after the expeditions during a year?
That's a really great question, and it's a hard one to answer. I'm intrigued by the coming publication in the deep sea research, because oftentimes scientists take years to actually work up samples after an expedition. Particularly new species can take well over a year to describe. So for example, we went to the Galapagos in 2015, yes, and we are still having scientists work on samples, and we have easily over a dozen new ones. but they're still not in press because it just takes a long time for scientists to describe them. So it's nice when someone can say right away, oh, that's a new species. For example, with the purple orb, someone looked at it and said, no, this is brand new. But oftentimes it's not until a scientist has the sample in their hands and is looking at it that they can say for certain that it's new. So I would say we probably discover at least a dozen new species in a year, and depending on where we go, more or less than that. But again, I think it's a really challenging question to answer just because of the nature of describing species.
Yes, I can tell about it. It's, you know, it takes a lot of time to process the material and probably doing a little bit of DNA barcoding, and after that go through museum material. And if it's a microbe or something very small, you know, it might take a few years to do it.
Mm-hmm.
Well, I have another question. I think we have two of our former students were part of the Nautilus explorers. I think one was Luisa Dueñas in the Mediterranean.
I sailed with her.
Yeah, and Juan Mayorga.
Oh, wow, Juan, yes. Yeah,
they are both from our university, the Andes, and you know, for them, it's been you know, such an amazing experience to be part of the Nautilus and you know, feel, you know, that exploration. Could you remind us a little bit what is the process for a student to try to apply or be part of one of the expeditions?
Sure. So the best way for someone to apply for an internship is to go to the Exploration Trust, Ocean Exploration Trust webpage. So it's www.oceanexplorationtrust.org. And there's a whole section about the education opportunities and internships. And usually around November, we post the application, and they close sometime in January. And then we read through hundreds of applications and usually have only a few spots, unfortunately. But particularly if a student is in the US, it's easiest, of course, to bring them from a US university. But when we go to work with Columbia, it will be a great opportunity too to bring students out. I think regardless, definitely apply. We never know until that year how many spots we'll have, but we try to involve as many students as we can. And again, there are science, there are mapping, there are engineering, there are video, if anyone's interested in video, or science communication internships available. And usually they come out for 1 or 2 cruises. We try to give them 2 different cruises so they could see different experiences, different ways of operation or operating. And so usually they're out for about a month with us.
Yeah, I was supposed to join you guys for a little lap of an expedition in the Caribbean to Belize.
Mm-hmm.
And something happened with the air conditioning or something.
Oh, wow, yeah.
There was Peter Neuer or something, and I was like, oh my God, I miss it.
I'm sorry to hear that. Yeah, the funny thing about working at sea and something your students will all learn or should know is that anything could go wrong. And if you don't have the parts with you, then you end up stuck in port for a little bit longer than you hope. So knock on wood, we've been pretty lucky in recent expeditions to have a ship that's functioning and technology that's all functioning very well. But certainly regions like the Caribbean and the Gulf of Mexico were so warm that things like the air conditioning were critical to operations.
Yeah, I remember that. And also I was very surprised to see that you guys are now able to do experiments with deep sea organisms, like the one Peter is doing with octocorals. So it takes a lot of time to, you know, get the samples and put it back in special conditions. Could you tell me more about it?
Sure. So on certain cruises, scientists are able to do those types of things. Peter actually had a special condition, I guess, through the sanctuaries to collect live coral samples And so there, as soon as they get to the surface, we have to put them in very cold water and keep them in very, very cold water for the duration until we're able to ship them, and then ship them as quickly as we can to get to his lab, because it had to go all the way across the United States to get there. But he said they arrived in good condition, and he was able to continue keeping them alive in his lab for these experiments. So it's amazing, really, I think.
Yeah. Well, I think well, the last thing that I would like to ask is, this is a new class. We're trying to encourage the students to follow all the different expeditions and to be part of the chats and write their own logs about what they're doing. So if you want to tell us a final message about exploration, about studying the oceans, that would be great.
Sure. I mean, for me, exploring the ocean is exciting because you never know what you're going to find. Even seafloor mapping, that can be painfully boring to some. To me, you never know what is going to be revealed when you map a new area and how that's going to help impact the future studies that you're going to do. We're getting the results back from the mapping off the Channel Islands and finding that there are some really interesting submerged features that are pretty close to islands that nobody knew existed, that now we're going to be able to go look at. And so I guess I would just encourage students, the field of ocean exploration and the field of seagoing oceanography is broad. And even if you're not particularly interested in one aspect of it, there's usually some way, if you love the ocean, to get involved, or if you love technology, to get involved. Even if you want to, be the person who's inspiring people, the educator, all of these roles are very important. So I would say find what interests you most, and just approach people like Juan, like myself, and find opportunities to get into the field. That has definitely made a difference in my life, just finding those open doors, asking people if I could help, doing logs from shore, whatever needs to be done. And it will help open doors and get you to where you want to be, help you figure out your career. And I think that's also very exciting.
Okay, Nicole, well, thank you very much. It's been, terrific to have you in our channel and in our class. We will follow you in the next expedition during all July, and we really hope to have the Nautilus and the Ocean Exploration Trust in Colombia. We're working hard to make permits and everything easier, and now we have a safer country, so we really want to open it for research and exploration.
That sounds excellent. I look forward to continuing to work with you guys, and thank you for joining me today, having me be part of this.
All right, thank you so much, and have a nice day.
You too. Bye.
Okay, bye.